All right, so section 4.1, we're talking about ratios, rates, and unit rates. I have two vocab words for you to write down. If you want to find the spot on your notes that has the title, you could probably write these underneath of it. So you're writing down a rate is a comparison of two quantities that have different units. So for example, you could say something like, in 8th grade, there are 8 girls to every 5 boys or something. That would give us a rate with two different quantities. And then a unit rate is a rate with the second quantity is 1. So for example, when you look at gas prices, and it's like $1.78 right now, that means $1.78 per what? For what? A gallon. So that's an example of a unit rate, like $1.78 per gallon of gas. And we see unit rates all the time, all over the place. So if you want to pause your video and write this down. Mickey can type 120 words in 3 minutes. How many words can she type in 1 minute? So we're going to set this up and we're going to do words over minutes, like words per minute. So 120 words over 3 minutes. How many words can she type in 1 minute? 40. So 40 words per minute she can type. Okay, Zach can type 30 words in half a minute. How many words can he type in 1 minute? So what could I put to represent half? 0.5. How many words can you type in 1 minute? 60. So 60 words per minute. Okay, so the next question is talking about 4 cubic meters of silver has a mass of 41,960 kilograms. What is the density of silver? So on top of this question, I wrote in there density. We're going to do the formula for density. Anybody remember it? It's something divided by something.
Volume divided by mass.
So density equals mass divided by volume. Okay. So 4 cubic meters of silver has a mass of 41,960. What's the density of silver? So I need to do my mass divided by my volume. So 41,960 divided by, and the volume is 4. I just heard 10,490. And my label would be kilograms per meters cubed. Okay, so let's look at aluminum. Aluminum weighing 1,350 kilograms has a volume of 0.5 cubic meters. What is the density of aluminum? So mass divided by volume. So 1,350 over 0.5. So 2,700 kilograms per meters cubed. Okay, so I want you to pause your video and try these two problems. All right, so if I go over these two, so first one, we're figuring out the density of copper. So 44,800 divided by 5, you should get 8,960 kilograms per meters cubed. Your density of gold would be 9,650 divided by 0.5. So you're looking at 19,300 kilograms per meters cubed. And if you think about it, this makes sense when you talk about the density of the different metals. Like, for example, out of the 4 we calculated today, aluminum is the lightest. Why do you think out of the 4 we calculated today, you probably deal with aluminum the most in your everyday life?
Because it's the lightest.
Because it's the lightest, right? So like any kind of food items that's in a can, they're put in an aluminum can, right? Soda, like green beans, corn, anything like that that's canned is all in an aluminum can because it's the lightest. Because it makes more sense, because if you put stuff in like a silver can, think about shipping and trucking, like trucking that stuff across the United States. Those trucks can only weigh a certain amount, right? They have a weight limit, and you wouldn't be able to move as much product if the stuff weighed too much. So that makes sense why aluminum is used. It's also not as rare, right? So it's significantly cheaper than something like gold or silver or copper. Copper is expensive. So you got to think about those things. That makes sense why somewhere along the line somebody said, let's put these things in an aluminum can, and then it started being manufactured like that. Okay, so this next part, a band tour bus is traveling 525 miles from North Carolina to Orlando. In the first 5 hours of the trip, the bus travels 260 miles. What is the bus's average speed? So the equation's up here, but it's really small. Rate, which means speed, is distance divided by time. So they've gone a distance so far of 260 miles in 5 hours. What's their average speed? 52. So their average speed is 52 miles per hour. Okay, so if you look at the next part, the driver estimates that the entire trip will take 8 hours. If the bus keeps traveling at the same average speed, is the driver's estimate reasonable? So how many miles altogether is the trip? 525. If you're going 52 miles an hour, how many hours should it take you? How do you figure that out? How'd you figure that out?
Because each hour is 52 miles per hour.
Yep.
Well, miles.
Yeah.
So I took 8 times 52.
Okay.
And got 416.
Okay, so that's a way to figure it out. 8 hours that they allotted times 52 miles per hour, you got what?
416.
416. And is 416 enough for the trip? No, so it's going to be more. What'd you get?
You could also do like 525 divided by 52.
Yep. Either way, and you end up getting 10 point something, right? 09 maybe. So either way, it's showing you that this is hours. You're going to take about 10 hours, and then this would only be miles. So either way, you can calculate the fact that planning 8 hours for this trip is not a reasonable estimate. It's going to take longer. Okay, so the next question. This is talking about a 500 mile, like a NASCAR race, like Indy 500. In the first 2 hours of the race, the driver travels 356 miles. What is the driver's average speed? 356 miles. So miles per hour. So 356 divided by 2. 178 miles per hour. Okay, now we talked about this last hour, that you have to think about, is this a reasonable answer? So if I were to ask you to find the average speed of like a minivan going down the highway, 178 miles per hour would not be a reasonable answer, correct? Okay, however, this is like a NASCAR race. So 178 miles per hour, I believe, would be a reasonable answer. I'm not a NASCAR person, but I know this would be a reasonable answer. However, it would not be reasonable for like a regular vehicle. Okay? All right, so the second part. The driver estimates he will finish the race in less than 3 hours. If the driver keeps traveling at the same average speed, is his estimate reasonable? So he's racing at 178 miles per hour. How many miles are in the race? 500. What should I do with those two numbers? So how many hours is it going to take him to do 500 miles? 500 miles divided by 178.
Maybe like 3.5.
No,
So no.
2.8. So is it reasonable for him to say that he will finish in less than 3 hours?
Yes.
Yes, that would be reasonable because you're just under 3 hours. Okay. All right, the next part is talking about what would be a better buy, like price-wise. So Arnie can buy a 16-ounce box of cereal for $5.49 or a 20-ounce box of cereal for $5.99, which is a better buy. So whenever you're calculating these, you're going to always put the price. So you're going to put the money over the quantity every time.
So ounces.
So in this case, it's ounces. Sometimes it's pounds. Sometimes it's like per package or whatever it is. Okay, this case, it's ounces. So money over quantity. So this is the same no matter what you're calculating if it comes to like what's the better buy. Always money over quantity. So 16-ounce box for $5.49. So $5.49 over a 16 ounces. And then the other cereal box is $5.99 for 20 ounces. Now, we're talking about money here. How do you always round money? How is money rounded? 100. Money is rounded into the 100th, right?
Yeah.
You have two decimals with money. So $5.49 divided by 16. You get what? 0.34. So 34 cents per ounce is how you would write that. And then $5.99 divided by 16.
0.29.
So round to the 100th.
3.
So 30 cents. So 30 cents per ounce. So which one is a better price? The bottom price, right? 30 cents per ounce is cheaper than 34 cents per ounce. Even though you have to pay more for the box, it's still cheaper. And like the amount you're getting is a better deal per ounce. Okay? So I want you to try this next problem. So deciding which jar of peanut butter is a better price. So you're going to do money over quantity. So pause your video and calculate this. All right, so if I calculate this with money over quantity, so I have my 15-ounce jar of peanut butter is for $2.19 for 15 ounces, and my 20-ounce jar is $2.78 for 20 ounces. So my $2.19 peanut butter jar is how much per ounce? Okay, so 15 cents per ounce. And then my $2.78 peanut butter jar is 14 cents per ounce. So really not that big of a difference, practically the same. So this would be like if I'm shopping, this might come down to brand. Like, oh, I really like Jiffy peanut butter, or I think it's just Jif now, Jif. I really like Jif peanut butter better than like Walmart brand. So maybe I would buy the name brand because it's really not that much difference in price, right? Okay, this is an example not on your paper, but I added this. So the beautiful thing about today is we can do a lot of shopping online. And whether we actually shop online or you physically shop in person, the items are generally available for you to see online and to see how much it is at the store, before you go there, because now we have all these like, grocery pickup where you can order everything and put it in your cart and buy it online, and then you just pull up to the store and then they deliver it to you. So I know that like Walmart does that, Sam's does that, Hy-Vee does that, where basically you can look up every single thing online that they have in their store and know the price of it, and whether you're deciding to do grocery pickup or not, you can still compare prices and things because it's all on their website. So here's an example of some Pop-Tarts. So on the left you have Walmart, on the right you have Sam's. So we're gonna find out which one's a better deal. And this is, Walmart and Sam's are actually the same company, but they're, a different store. They're not the same store. So, all right, so this is a box of 48 value pack for $9.99. So if this is 48, does that mean 48 little packs of Pop-Tarts or 48 Pop-Tarts?
48
What do you,
Pop-Tarts.
okay. It is not actually. It's 48 Pop-Tarts. So how many packs of Pop-Tarts is that?
24.
There are 2 in every pack, right? So this is actually only 24 packs of Pop-Tarts. That's
So-
kind of misleading, but that's how they package it. So then how would I figure out the price per pack of Pop-Tart?
So by 9.98 by 24.
So $9.98 divided by 24.
What'd you do? 24 or 24?
24 packs. So $9.98 divided by 24 packs. How much are those Pop-Tarts per pack?
4.41.
So, 0.42.
So 42 cents per pack, right? Okay, so now look at Sam's. Sam's is a 36 pack. 36 Pop-Tarts. So how many packs?
13.
What?
18. Thank you. 18 packs of Pop-Tarts for $6.78. So $6.78 divided by 18 packs. So 38 cents per Pop-Tart, right? Or per pack, I'm sorry. So which one would be the better price? If it's something like you eat Pop-Tarts every day, getting it from Sam's is gonna end up saving you money. Now, Sam's is not always the cheaper place to go. However, in this case, with the comparison of the two, Sam's happens to be the cheapest, okay? All right, so we're gonna skip this problem, and your assignment is on page 158 and 159.